Hello everybody, day 2. This is Tuesday, April 3rd. Okay, so these notes are, hopefully you finished the homework and the notes from yesterday. If you were absent yesterday, you have 2 days of this to do, so get busy. You have to do Monday's busy. Ask the sub for Monday's notes and Monday's homework, and there's also a syllabus on Monday. So if you were absent, make sure you get the sub to look for Monday's folder and hand you the notes, homework, and syllabus, and it's a video on the notes and homework on Google Classroom. Look for under Monday, April 2nd. So today is Tuesday, April 3rd, and we're doing common logarithms. Now there's a key on your calculator for common logarithms. It's right here. It's this log right here. That key right, oops, can't see. This key right here, log, is a common logarithm. It has a base of 10. Look right above it. See how it says 10 to the x? Okay, so log right here is a common logarithm. It's on your calculator. We're also going to be using natural logarithms. There's also a key for this. It's right under the log. It's the ln, natural log. I know it's ln, but it's logarithm, natural logarithms. So these 2 keys are what we're going to be using today on our notes and homework. And change of base. Most of you don't need to do this change of base because you have that special key alpha window to get to the log key. It gives you this log with a blank box. But some other people, we might use this change of base to use our calculator. Okay, so today we're going to identify common logarithms and approximate by calculator. We're going to evaluate common logarithms with powers of 10. We're going to identify natural logarithms and approximate them by calculator. We're going to evaluate natural logarithms of powers of e. And we're going to use the change of base formula. So the first one, log x means log base 10 of x. So if you do not see a base, it means it's a common log and it's base 10. So it says use the calculator to approximate log 7 to 4 decimal places. So again, this means base 10. So before we even punch this in the calculator, let me just show you what this means. There's an x here, correct? When you set up an equation. So this is really, if you do swoop, 10 to the x is 7. Now 10 to the first is 10. 10 to the 0 is 1. So your answer is between 0 and 1. But we don't need to do this. You can just punch this right in your calculator. So we're going to go log 7. So log, press log right here. It's right there under the x squared. Press log 7. Looks like that. Let's close our parentheses just because I don't like it open. Press equals. And we want 4 decimal places. So our answer would be 0.8451. Because the 9 rounds the 0 to a 1. You see that? The 5th number there. So you look at your 5th number to see if you have any rounding or not. If it's 5 and above, bump it up. 4 and below, let it go. Remember that? So it's 0.8451. Pretty easy, huh? Find the exact value of each logarithm without referring to your calculator. Now, let's not kid ourselves. You're going to have a calculator on this test, so you can punch this in your calculator. But wouldn't it be nice to know how to do this without a calculator? So remember, there's a base 10 here, correct? I can write, well, let's just do it like this. So really, it's 10 to the x equals 100. 10 to the what power is 100? Most of you probably already know this. Your answer should be 2. Let's punch log 100 into our calculator, though. Log 100. See how it's 2? The reason it's 2 is because with base 10, if you get powers of like 10, if you have 2 zeros, that's what your answer is going to be. So if I said what's log of 10,000, since there's 4 zeros, your answer is going to be 4. Try it on your calculator. Log 10,000. So this answer is going to match the number of zeros in the problem if it's a base 10 number. That means if you start with a 1. So what would log 1,000 be? 1,000. How many zeros are in 1,000? 3. So log 1,000 would be 3. And hopefully you know that million has 6 zeros. So if you did a log of a million has 6 zeros. Log of a million is 6. Okay. So this is also a power of 10, but it's in a fraction form. So most people think of 1/10 as 10 to the negative 1. So if this is a base 10 and these cancel, these are going to cancel, your answer should be negative 1. Let's try it on the calculator though. Log 1 divided by 10. negative 1. Log square root of 10 is really log 10 to the 1/2. You always want to try to get it in a power of 10 if you can. These 10s will be our inverse operation, so your answer should be 1/2. Let's try it. Log square root of 10. 1/2, 0.5. So natural logs. So ln, sometimes people will say line x, but it's not. It's natural log of x. That's how you say it. When you have a natural log, there's a base e here. So not natural log of x also means log base e of x. Use a calculator to approximate natural log of 8 to 4 decimal places. So there's a key right here. See it? Natural log, ln, press it, press 8. Looks like that. Press equals. 4 decimal places. So this is 2.079. That's 3 decimal places. And then 4. The fifth number is at 4. 4 is 4 and below. Let it go. So we're not doing anything to that first 4. So it's 2.0794. Find the exact value of each natural logarithm. So if you know your properties, you don't have to do a whole lot of work. So if you see a natural log, it means there's a base e. So these e's will cancel because they're inverse operations, and your answer should be 3. But if you punch this in the calculator, you do natural log of e. Now e is second division sign. Close your parentheses, I think. Wait, do I close my parentheses? I think so. And then cube it, like that. Answer, shoot, I don't think you do that. Okay, I was wrong. So I think it's got to be in parentheses. I'm wrong, don't listen to me. Natural logs, I never punch these in the calculator. Second division, the 3's got to be on the inside of the parentheses. That, oops. Delete that, make a big parenthesis. There. Punch it in like that. I think that's the better way. There's the 3. The answer is definitely 3. So you have to be careful how you punch it in. See, that's wrong. This is right. Answer is 3. So what's another way? Remember the lesson we did yesterday? Remember this 3? We can bring this out front. 3 natural log e. Whoops. Let's try that again. 3. I have to do cursive because I can't write ln straight. So this is 3 natural log of e. Natural log of e, because there's an e here, because these cancel, is just a 1. Anytime you see natural log of e, it's just going to be a 1, so your answer would be 3. Let me just show you that. Natural log of e is 1. Because the e's cancel. Just like this one, log of 10, it should also be 1, because there's a base 10, and that's 1. Gosh, you can't see my calculator. So natural log of e is 1, natural log of 10 is 1, because both this base is 10 and that base is e, and they cancel. All right, and then b is natural log of e to the 1/5. You should make that a fractional exponent. So I'm going to bring this out front. 1/5 of natural log of e. Natural log of e is 1. So 1/5 times 1 is 1/5. Now 1/5 is like approximately 0.2 as a decimal. So when you punch this in your calculator, natural log of the 5th root. Now to get 5th root of e, you have to press math, and you want this number 5, but it's 5th root. Okay, I have to do that again. All right, so I'm not sure how to punch this in. Log 5 math 5 of e. Second division. Here we go. So it looks like that. Answer 0.2. Backside. Solve each equation. Give exact solution and then approximate solution to 4 decimal places. So when you solve equations with a log on one side, this is very important for a thing that we're going to do on Thursday. Logs on one side. You roll that log, aka swoop the log. Oops. AKA we're swooping. Swoop, swoop, swoop. So that you only swoop when you have a log on one side. All right, so we have a log. See how we have log on one side. There's no log over here, just a log on one side. We have one single logarithm in this problem. What is the base? The base is 10. You have to fill in the 10. So you're going to put the 10 in the base spot. We'll call it spot. Go ahead and put it in because we can't swoop without a base. So once we have the base in, then we're going to swoop. So it's 10 1.2 equals x, and then you're going to write 10 raised to the 1.2, and that equals 15.8489. Now, wouldn't it be nice if there was another way to do this? Let's look at here. So log x equals 1.2. You can get rid of a log by taking something called the inverse of log. The inverse of log is log, looks kind of like something like that. Log -1, like that. That's what inverse means. And these would cancel and you just get x. And then to do that, to do inverse log, you're going to press second log. Now look what that does. It does 10 to whatever number you put in. So it's second log of 1.2, which is 15 point. It's the same answer. So keeping that in mind, let me do the swoop first, and then I'll do it the other way. So let's do swoop. In order to do swoop, we need a base. What's the base of natural log? Hopefully you're saying e. Okay, so e to the 5th is equal to 3x. And then solve for x, we're going to divide by 3. So punch that in your calculator. E raised to the 5th divided by 3. 49.4711. So that's not how I do it like this. So whenever I see a natural log, you can get rid of natural log by taking inverse log of both sides. And that's going to cancel this, and you'll still have a 3x. On this side, inverse natural log of 5 means you press second first, then natural log, and then you put in the 5. So you get this answer, 148.4, all that stuff. And then you divide it, because there's still a 3 out front, you divide it by 3. You get the same answer. So do it whichever way you want. Now there's a formula, PERT, that you use when it says compounded continuously. Compounded continuously. It's one of our compound interest formulas. You only use you only use E if it says the word continuously. So it's A equals PE to the RT. I call it the PERT formula. So P is your principal. Find the amount owed at the end of 5 years if $1,600 is loaned. So this is your principal. This is what you're taking out in your loan. E is loaned at a rate of 9% compounded continuously. So the rate is 9%. That's an exponent, by the way. And you write it as a decimal. 5 years. See the 5 years right here? And we're going to find the amount of money owed. So we're going to go 1,600. E raised to the 0.09 times 5. Older calculators, you need parentheses around the 0.09 and the 5. So at the end of 5 years, you will have paid the person that you borrowed from $2,509.30. That's how much you would have paid them at the end of 5 years for taking that loan out. So it says change a base. This is only needed if you have an old calculator. If you have a new calculator, you know how to punch this in the calculator. Log base 5, you're going to go alpha window. So you go alpha window, number 5, and it gives you what you need. Just do 5 and 3. So to 4 decimal places, it's 0.6826. Now, for those people that have an old calculator, you do need to know how to change a base formula. So if you have this problem right here, change a base means we're going to change it to base 10. To go to base 10, that means our common logarithm. That means we want to use our calculator. You change it to log base 3, which is actually base 10, but you don't see the 10. But log base 3 divided by log 5. How you punch it in. So you press log 3, close your parentheses, divided by log 5. You get 0.6826, same answer. Okay? And for those, again, if you have the calculator alpha window, do alpha window, 5, It says 1/3. And it says 4. Answer, negative 0.12619. And for those people that don't have a new calculator, you do log base 4 divided by log base 1/3. And you'll get the same answer. Now on this time, I'm not going to make 2 separate videos. I want to continue doing the homework. It's just one side. Use the calculator to approximate each logarithm to 4 decimal places. We're using our calculator, people. Let's do it. Log 6. Log 6. 0.7782. Next problem. Natural log of 41.5. So natural log 41.5. 3.726. 7257. Oops, I'm wrong. 3.7257 because we need 4 decimal places. And log 3.47 is log 3.47. We're just punching it in, and you get 0.5403. Find the exact value of each logarithm. So without referring to your calculator, what this means is that there's a base 10. These are going to cancel, and your answer is 3. Feel free to punch that in the calculator. You will get 3. This one, this is a tricky one. So if this is base 10, 0.01 is 1/100ths. So this is how you write it as a fraction, 1/100, which is 10 to the negative second. So your answer is -2. This one might be an easier one to punch in your calculator though. Log 0.01 is -2. Natural log of square root of e is really natural log of e to the 1/2. Bring the 1/2 out front. Natural log of e is just 1, so your answer should be 1/2. But again, you're welcome to use the calculator. So it's the natural log of the square root of e, and your answer is 0.5. Solve each equation, give exact solutions and an approximate solution to 4 decimal places. So if you do swoop, put a 10 in. It's 10 to the 2.1 equals x. Punch that in your calculator. Or if you want to do the inverse log, you press log inverse to get rid of it on this side and press log inverse here. So on your calculator, you'd press second log 2.1. But I'm just going to press in the 10 raised to 2.1. You get 125.8925. This one, let's do inverse natural log. Inverse natural log. Inverse natural log. Cancels the logs and you get 4x. So on your calculator, press second natural log of 0.18. And you get 1.1972 divided by 4. And you get 0.2993. If you want to do the swoop method, it'd be e to the 0.18 because you'd swoop equals 4x, then you divide by 4. So just punch that in. Same thing. Let's just do swoop. 10 to the negative 0.5 is equal to 2x plus 1. We're solving for x, so take 10 to the negative 0.5 minus 1 equals 2x, and then divide everything by 2. So x equals all of this. So let's punch all of that in. Oops, you can't see it. So I took 10 to the negative 0.5 is equal to 2x plus 1. I subtracted 1 and then divided by 2. So we're punching all of this in. Be careful. This is a 0.5 right here. So it's 10 raised to the negative 0.5 minus, let me get out of that, minus 1 equals. Now divide it by 2. So it's negative 3419. For the next one, there's a base e, so we're swooping. E to the 2.3 is equal to 3x minus 4. to solve for x, we want to add 4 to both sides. So you're going to have e to the 2.3 plus 4 equals 3x. And then you're going to divide everything by 3, and you're going to get x equals, and this is what you're punching into the calculator. So to punch that in the calculator, press second division to get the e, raise to the 2.3, right arrow to get out of that exponent, plus 4 equals divided by 3. The answer is 4.6581. Approximate each logarithm into 4 decimal places. I'm going to use alpha window 5. So it's 2 there and a 1/5 here. Answer is negative 2.3219. If you want to use the change of base formula, it is log of 1/5 divided by log 2. That's also another way of getting the same answer. Log base 4 of 7. Let's go alpha window. Oops, something didn't right. Alpha window 5, 4, 7 for a 1.4037. Or do log 7 divided by log 4. Same answer. And use a formula PERT to solve. So $1,400 is invested at 8% compounded continuously. So the 0.08 goes up there in the exponent, and it says for 12 years. So that's times 12 years. So we're going to punch that in your calculator. It's 1,400 e raised 0.08 times 12. So you would have this much money at the end of 12 years if you invested your money. Find the amount of money for which a $2,500 certificate, so let's start with $2,500, is redeemable if it has been paying 9% interest compounded continuously for 3 years. There's your E. Your interest rate's 0.095 for 3 years. So it's 2,500 E raise 0.095 times 3 years. So 3,324.41 cents. And that's your homework.